Hello again. In our last video, we learned how to test an equation for symmetry algebraically. Now we are going to combine several ideas. We're going to combine the idea of points, intercepts, symmetry, and graphical behavior. So we will begin with a basic problem and gradually increase our level of reasoning. So the first example I want to look at is find the intercepts. The first example is find the intercepts. We want to find the x-intercepts and y-intercepts of the equation y equals x squared minus 4. So find the intercepts for this particular equation. So let's begin with x-intercept. Remember, in order to find the x-intercept, we let y equal to 0. And letting y equal to 0, we have 0 equals x squared minus 4. Add 4 to both sides. We end up with 4 equals x squared. We take the root of both sides. Our answer is plus or minus 2 equals x. Now, again, let y equal 0 if we want to find the x-intercept. So the x-intercept is -2, 0, and 2, 0. Now let's find the y-intercept. In order to find the y-intercept, we let x equals 0. Okay? Letting x equal 0, we have y equals 0 squared minus 4. Y equals -4. So 0, -4. So the y-intercept is 0, -4. So just again, the x-intercepts are -2, 0, and 2, 0, and the y-intercept is 0, -4. Example number 2. I do apologize. I don't know if you can see that. The final result for this one was -2, 0, and 2, 0, and 0, -4. So those were the intercepts for that particular problem. Okay. Example 2. We're going to analyze intercepts and symmetry. So we want to determine some things about this, and we want to determine essentially the intercepts and symmetry of a particular equation. So suppose if we have y equals x squared minus 9, okay? And we want to determine the intercepts and the symmetry for this particular problem. So first we want to find the x-intercept. So the x-intercept, we set y equal to 0. Add both sides by 9. We end up with 9 equals x squared, root 9, root x. squared plus or minus 3 equals x, negative 3, 0, 3, 0. So the x-intercepts is negative 3, 0, and 3, 0. Now we want to find the y. So again, that's y equals 0 squared minus 9. Y equals negative 9, 0, negative 9. So the y-intercept is y equals 9 or 0, negative 9. The x-intercepts are x equals plus or minus 3 or negative 3, 0 and 3, 0. Now we obtain the original, or excuse me, now we're going to look at symmetry and determine whether or not this has symmetry at all. Because remember, you can have symmetry or you cannot have symmetry. So we're going to test that. So let's test for symmetry for the y-axis of symmetry. So when we're testing this equation for the y-axis of symmetry, see if I have enough room down here. Okay, so we're still looking at the same problem. So we want to test this for symmetry. So we want to write this as such. If we're testing for the y-axis of symmetry, remember we replace x with negative x. So just going to abbreviate y-axis of symmetry there. Okay. In testing for the y, remember, we replace the x with a negative x squared minus 9. We can compute this very easily. Y equals x squared minus 9. So we go from the original equation, which was this right here, and we ended up with the original equation here. So therefore, the graph does have y-axis of symmetry. So y symmetry checks out. Now think about what that means. The x-intercepts are negative 3, 0 and 3, 0. So these points are mirror images across the y-axis, right? So if this point would occur on this side, and that point would occur on the other side, and they are reflective of each other. So you have to understand that these points are mirror images across the y-axis. So the algebra and the geometry both agree. Okay, if I were to sketch this out, this graph is actually a parabola. So negative 3, 3, excuse me. So the first point would be here at 3, 0. The other point would be here at negative 3, 0. Okay. And then we have 0, negative 9. So 0, negative 9. The 9 would be here. And so again, this particular graph would look like that. This graph is called a parabola. So just to kind of give you an idea, and notice it is a reflection across the y-axis. So the reflection is across the y-axis. It's not reflective across the x. Notice they don't have a reflection here, but they have a reflection across the y-axis in testing for y-axis symmetry. Okay, let's continue. Example number 3. We want to analyze before graphing. We want to analyze before graphing. So let's consider the equation y equals x squared plus 4. Before graphing this equation, you have to ask yourself the following questions. You have to ask yourself, does this graph have any real x-intercepts? Okay, that's number one. Number two is, what is the y-intercept? And number three is, what does the graph, or excuse me, does the graph have y-axis symmetry? And then finally, what can we conclude about the location of the graph? So let's begin with x-intercepts. Okay, so again, let me write those questions down because you might have them for reference later. Does the graph have any real x-intercepts? Okay, I'm just going to abbreviate these. So any real x-intercepts, y-intercepts, y-axis of symmetry, and can we conclude, or excuse me, what can we conclude about the location of the graph? Okay, so those are essentially the four questions we must ask ourselves. So let's begin, of course, with the x-intercepts. And again, we need to let y equal 0. So I'm going to just rewrite the equation first. Plus 4. Let y equal 0. So 0 equals x squared plus 4. Subtract 4 to both sides. We have negative 4 equals x squared. So again, we run into that issue. So this equation, or in this equation, there is no real number whose square is negative 4. We concluded that earlier. So therefore, this particular equation has no real x-intercepts. So none. Okay. So you always have to ask yourself this when you're analyzing a graph. So, or excuse me, analyzing an equation before graphing. Are there any real x-intercepts? Okay. So that's how you determine that. Since there's no real x-intercepts, we can move on to letting x equal 0 to find the y-intercepts. So y equals x squared plus 4, y equals 0 squared plus 4, y equals 4. So y equals 4, therefore the y-intercept is 0, 4. Now, we know that the answer to this question is here. So we have 0, 4 as the response to this question. And then the next thing we want to do is look for y-axis of symmetry. So when you're testing whether or not an equation has a y-axis of symmetry, you have to remember what we looked at earlier. So this equation is substituted when you're testing for y-axis of symmetry with from x to negative x. So okay. So remember, you're going from x to negative x. So we take y equals x squared plus 4, y equals negative x squared plus 4. This is terrible. Parting my writing errors. Negative x squared plus 4. Y equals x squared plus 4. So notice we started here and we ended there. Okay. We started at y equals x squared plus 4. We ended at y equals x squared plus 4. So the equation remains unchanged. Therefore, this graph has y-axis of symmetry. So the answer would be yes. So we've determined that. So therefore, this graph has y-axis of symmetry. Now let's reason. So we know that the graph has no real x-intercepts. We know that the graph crosses the y-axis at 0, 4. And we also know that this graph is symmetric with respect to the y-axis. And since x squared is always greater than or equal to 0, x squared plus 4 is always at least 4. Again, since x squared is always greater than or equal to 0, remember, because you can't have a number, if you any squared number, it'll either be 0 or greater than that. So since x squared is always greater than or equal to 0, x plus 4, this right here, x squared plus 4 is always at least 4. Okay, so again, if you put in any number in here, it's always going to be at least 4. So therefore, we write y is greater than or equal to 4. Okay, so that's what we can conclude about this graph. So again, we know that there aren't any real x-intercepts. We know that the y-intercept is 0, 4. We know that it is reflective across the y-axis. So what can we conclude? We can conclude that y is always going to be greater than or equal to 4. So before drawing the graph, we already know that the entire graph lies on or above the horizontal line y equals 4. Okay. And so this is an example of using algebra to predict the graph. So we know that this graph okay? So we know that this graph will lie on or above y equals 4, which is a horizontal line. Okay, let's continue. The next example I want to look at is I want to compare two equations. So example number 4. When we compare two equations, let's say I'm going to say EQ, we'll just give it equation A, and then we'll call this one equation B. So equation A, for example, let me just slide this over. Equation A, we're going to say y equals x squared minus 4. And then for equation B, we're going to say y equals x squared plus 4. Okay. Without creating a table of values, how can we explain why equation A has two real x-intercepts while equation B has none? Because we have to reason through this. For equation A, y equals x squared minus 4. So we have to find whether or not the determination is true when we're comparing these two. So the first thing we want to do for equation A is we want to find the x-intercept of equation A. So equation A is y equals x squared minus 4, and we want to find the x-intercept. So we let y equal to 0. So we have 0 equals x squared minus 4. Add 4 to both sides. 4 equals x squared root 4 root x squared plus or minus 2 equals x. Okay. So again, letting y equal 0, we substituted 0 into the equation. 0 equals x squared minus 4. Add both sides by 4. 4 equals x squared. Take the root of both sides. You end up with x plus or minus 2 equals x, or x equals plus or minus 2. So both solutions exist. Therefore, the graph crosses the x-axis twice. Now, let's consider equation B. So we're going to let y equals 0 for equation B. We have y equals x squared minus 4. I made a common error right here, so that's actually addition. So plus 4. Subtract 4 to both sides. We have negative 4 equals x squared. And remember, there's no number squared that would generate 4 or negative 4. So x squared equals negative 4. And what does this say? That says that there are no real solutions. Therefore, the graph does not cross the x-axis. But I want you to go one step deeper. Since x squared is always greater than or equal to 0, okay? So just remember that x squared is always greater than or equal to 0, always. Okay, x squared is always greater than or equal to 0, no matter what number you put in there. If it's a negative 1 squared, it's always going to be greater than 0. 0 squared is always going to be greater than, it's always going to be equal to 0. So you can't have a number that is squared that is going to be less than 0 ever. So if that's the case, then if we know that is true, then we can say this. We can say that, let's put my boundary here. We can say, as a matter of fact, I could do it right here beside this. Bring this down so you can see all of it. We can say that x squared plus 4 is greater than or equal to 4. Because since x squared is greater than or equal to 0 no matter what, then x squared plus 4 is going to be greater than or equal to 4. So the graph of y equals x squared plus 4 can never even reach the x-axis. And so this is stronger reasoning than simply saying that there are no real solutions. So we're essentially able to explain why there are no real solutions in this case. So let's do this. Let's do this. I want you to try this problem here. Y equals x squared minus 16. So before continuing, I need you to pause the video and determine these things. Determine x-intercept, y-intercept, symmetry, whether the graph crosses the x-axis, and then explain why your answers are consistent with one another. So pause the video now and attempt the problem before continuing. All right, now I want to do those things here. So 0, let's just say we're going to set, if we're looking for the x-intercept, we're going to let y equal 0. So 0 equals x squared minus 16. Add 16 to both sides. 16 equals x squared. Take the root of 16, the root of x squared. You're going to end up with plus or minus 4 equals x. Therefore, negative 4, 0, and 4, 0 are the x-intercepts. And then for the y-intercept, we have 0 squared minus 16. So y equals negative 16. Therefore, the y-intercept is 0, negative 16. For symmetry, we're going to replace x with negative x. So we have y equals negative x squared minus 16. Y equals x squared minus 16. Therefore, the answer is yes, it has y-intercept or y-axis symmetry. So let's connect the ideas. We have the two x-intercepts of negative 4 and 0, negative 4, 0, and 4, 0. And those are mirror images across the y-axis. And that's consistent with it having y-axis symmetry. And the graph crosses the x-axis twice because the equation x squared equals 16 has two real solutions. Okay. Moreover, a common error that people make is this. The graph of y equals x squared minus 16 has only one x-intercept because they'll say, well, root 16 is 4. Well, if this wasn't an equation, then sure. But what's wrong with this reasoning? When solving x squared equals 16, we must include both x and we must include both answers in our solution. So when we're taking the radical of both sides, we're going to end up with x equaling plus or minus 4, not this one. So this is a common error. That students make. They say, well, it's just 4, but you have to include both variables, both in this situation. So there are two x-intercepts, not one. So this student forgot the negative symbol. They just only included the positive and not the negative. Okay. So just a final recap. To analyze a graph from its equation, you find the x-intercepts and you find the y-intercepts. And then you test for symmetry and you use the equation to predict graphed behavior. So we can easily graph this because we have 2 points on the x and we also have this. So we know that it's going to cross the x-axis twice, and we know it's going to be, this is going to be across the y-axis. So we know that this will be a parabola. We know the behavior of it, but we can use the equation to predict the graph behavior. So the goal is not simply to calculate isolated numbers. The goal is to connect the information. Intercepts tell us where the graph meets the axis. Symmetry tells us how the graph is reflected, and the algebra can help us predict the graph before we even draw it. Now, that concludes video 2. In our next video, we will begin studying lines and slopes. And again, thanks for watching.